So hello, welcome everyone. Hope you're having a great DevOps so far. So let's start with introducing you a bit to me. So, well, I know who I'm talking to. Who has ever felt like this guy over here when working on a code base? Please raise your hand. Yes, quite a lot. You know that feeling when you need to modify your code, that you have a hard time finding where you need to be. And when you finally found that spot, the code is hard to read. And related code? Yeah, there's related code, and you will find out the weekend after it's deployed to production. It's definitely not where you want to be. Well, thanks for sharing that with me, so many persons. Let me return the favor, tell a bit about myself. My name is Jos Roseboom. I'm a freelance Java software developer from the Netherlands. And yeah, I've definitely been into this situation as well, where basically you need to put too much information in your head to comfortably reason about it, resulting in some kind of StackOverflow exception in your head or a brain explosion. And that's not very nice. First of all, it's not very good for your mood. But next to that, you also make more mistakes. And it also makes you slower. So not only this is bad for you as a developer, but also for your company. It costs money. A lot of research has been done on that, and I want to name just one. A poll done by Stripe in 2018, where they estimated the yearly cost of the extra time, so just the extra time that developers need to reason about low-quality code, is $85 billion. So every year, and just the extra time that developers need to reason about that. Now that's a huge amount. To put it a bit into perspective, they estimated that to be 9% of the developer work week. Recall that here technical debt, so time fixing it is way more. Now, as I said, I work as a freelancer, and 2 years ago I was in a project where we definitely felt this need. And we decided to fix that. It was just too complicated, it was slowing us down. So we felt that the overall structure of our code was not very clear. Now, structure, if you look for structure in the dictionary, it says something like the way we build things from other things. And in Java, we build things, don't we? So we can apply the definition to Java. And if we do that, it looks something like this. So we have an instruction like C is B plus A. We group those instructions into methods. We group those methods into classes that can be inner classes. We group them into packages, which can be nested. And we put them into jars, and ultimately we deploy that. Now, all the decisions we make there along the way are important, of course, for the overall structure and clarity of our code. But today in this talk, we will just focus on the package level. So basically the decision we make, what classes do we put in what packages, and how do we nest them? So what packages do we put in other packages? And we all have to make those decisions, don't we? You don't just put all your classes in a root package. We have to make some structure there. And what we typically do is we group them by the technical role those classes represent in our application. So an example here, it can be a controller, a service, a repository. Names could be different, and well, there could be others as well, like DTO, request response, stuff like that. But the key thing that I want to point out here is that we group them by the technical role they represent in your application. Now, when your application grows, multiple of those services, controllers, repositories come in, and well, we solve that by sub-packaging. So typically what we do within our service, we have an order and a product sub-packages. And that solves the problem of having really big packages. But for us, that was not a solution to our problem, because basically our problem was like represented here. What you see here is the dependencies between all those root packages. And here we have this controller, we have the servers, and somewhere buried under all the blue lines here is a repository thing as well. Dashed lines here indicates a circular dependency, complicating matters even more. But even if you don't take that into account, this is a mess, causing the brain explosion that I was referring to. Now, if you think about this, within this grouping by the technical role classes represent your application, we cannot really solve it, because a product controller uses a product service, and a product service uses a product repository. That relation makes perfect sense. But since we group them by the technical role, so the controller and the service, they are in different root packages. And we cannot properly encapsulate that stuff. And well, that resulted in related code all over the place, making it hard to reason about. So what we decided to do instead is slice it vertically. So grouping them by the subject or the feature or bounded context in terms of domain-driven design that they represent. So it looks a bit like this. You have the order package, and within that you have, well, the different technical roles in your application. So the service, repository, controller. And that way we could properly encapsulate stuff within a package, simplifying our code. Now, you might say, okay, Jos, this is a nice idea, but this is already solved. You're a few years late. Because didn't we have microservices for this? Maven modules, maybe even Project Jigsaw. And while that's true that they can help you encapsulate stuff, they all work on the jar level. So if you look at the structure diagram here, here we have our Maven modules, Jigsaw, and microservices. But so far in this talk, I was talking about this level. Now, we could use those solutions, so just promote, I don't want to say promote, change for every package, create a jar. We could do that, but it's kind of a verbose solution, means you have to create a separate project for all those packages. And well, if we use microservices as a solution, it complicates your deployment, because well, we have to deploy all those jars. And it makes refactoring harder, because we change our method call for a remote procedure call. We lose type safety, making it harder if you have to refactor stuff. And even if one day we want to end up with a microservice, we would highly benefit if, at this level, we already grouped stuff by a related feature. And maybe, even maybe, that day never comes, and it's just fine that we have a properly encapsulated package here. So that having said, in Java, we kind of have a lack of force. So circular dependency between one of those root packages, the compiler says, go ahead, no problem. Access restriction, well, Java offers a bit of help there with package private. So if you omit the public keyword for your class or your method, that class or method can only be used within its own package. Now, let's do a quick raise of hands here. If you create a new class in your IntelliJ, it says public class, blah, 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 blah. Who of you take some time to think about whether that public keyword is needed or we can remove it? Who does that? Yes, quite some, but I think a little less than half. So if you can do that, that's a very good idea. Java already offers us the tools to force that encapsulation, and that simplifies our code. But even using that or start using that is not really enough, because sometimes we want to have this class to be used from another package. So what do? We have to make it public. But if you make it public, not only that other package can use it, the entire world can use it. And that's where, for us, Spring Modulith came into play. Spring Modulith is a product from Spring. Yeah, you might have guessed that from the name. It works with Spring Boot 3 and above. And Modulith here is kind of a blend between modular and monolith. So a monolith is something we deploy as a single unit, so with the advantage of, well, a simple deployment, but it's kind of infamous for turning into a big ball of mud over time. And well, the modular thing in the name is exactly the aim of the Spring Modulith project, to modularize that monolith. So we keep the simple deployment, but we prevent it from turning into a big ball of mud. It does so, well, by some opinions on how to do it. And one of the things is circular dependencies are not allowed. It also offers a more fine-grained control for access restriction, which I will come in detail a bit later. And it does so by having a failing unit test if you violate any of those conventions. So basically it uses ArchUnit to do so. So no need to wait for some build deployment pipeline to give you feedback. It just fails on your own system before you commit and push, given you run the unit test, of course. But that's another story. Now, how do I do that? Well, that's a good question, and let me switch to my IntelliJ to show you that. So here we have the demo project, a freelancer finder project. So it's a demo project for this talk, but also it's a very important application because, as I said, I'm a freelancer, and it's important that the world like you can find people like me. So that having said, for now it just serves it as a demo application. It's just a simple Spring Boot application, and here we have the entry point of it. Nothing fancy about it, but still I want to show you because of the first convention of Spring Modulith, and that is the definition of a module. So a module by default is a direct subpackage of the package that has the entry point. So in this case, this is my entry point of the application. So com.easingu.freelancerfinder hosts that, and a direct subpackage here is bidding. So bidding is a module in terms of Spring Modulith. As is freelancer, as is review, review.analysis is considered an internal package of the review module. So that for the first convention of Spring Modulith. Now the first feature that I want to show you is the easy way of writing documentation. Basically, what we can do here in a unit test is that we gather an application modules object. Application modules here is a class from Spring Modulith. We do that by using this factory method and feeding it the class. Yeah, recall that this is the entry point. And then we feed this to a documenter and just tell it to write documentation. That's about it. So let's run the unit test. And it passes, and what it has done in my target folder here is Spring Modulith docs, which is a collection of ASCII doc and plant UML. And if I click on that and with the proper plugins, I can render that in my IntelliJ. It shows me how my application looked. So here we see review, bidding, freelancer, you know, the modules that I already told you, but it also shows us the relation. So here depends on mean I cannot compile without you. Uses means I use a Spring Bean of you. So of course it cannot compile without freelancer as well, but it uses a Spring Bean. There's also a listen to, meaning I listen to an event of you. And if we scroll down, you see even more detailed information. For example, here in my review, I see the Spring components that this module defines itself, and also the bean references responsible for the users relation. Now this is very good, and for now it gives an overview of how the relations of my demo application are. But the true power is in this test, the test that I was referring to on the slide. And basically here I do the same. So I gather an application modules object, just as I did with the documentation writing, but I call the verify method on it. And basically the verify method validates those conventions of Spring Modulith. So let's run it, and it passes. And well, what does it mean that this passes? It means there are no circular dependencies. Okay. That's right, no circular dependencies. And we didn't violate against the access restriction rules of Spring Modulith. To start with circular dependencies, if I have a circular dependency, how will that look? Well, let's be a bad boy and introduce a circular dependency. So we see here that bidding already depends on the freelancer module. So if we expand that, I see I have a bid service and a freelancer service. So if I refer to the bid service from my freelancer service, then okay, we agree that this is a circular dependency, isn't it? So let's run the unit test and see what happens. Well, it fails. Of course, you might expect that. But not only it fails, it also tells me why it fails. First of all, a cycle is detected, a circular dependency. From bidding to freelancer, again to bidding. And then it also lists what dependencies are responsible for that circularity, which is really convenient in real life because you want to break that. So knowing what dependencies are responsible is very nice. So here it lists basically the class bid has a field freelancer of the type freelancer. And I can click on that. So it's this one. And that is the dependency from bidding to freelancer. And the other end, freelancer, the freelancer service has a field bid service of the type bid service. Well, of course, I just added that. Now, if you have a big application where you use Spring Modulith and you introduce by accident such a circular dependency, you will see that one of those lists is really big, and that is the direction that you allow by your architectural IDE. And the other one is quite small. Those are the dependencies that you accidentally introduced. So yeah, that's what I want to tell about the basics. So let's do a quick recap. First, the definition of a module. By default, that is a direct subpackage of the package that holds the entry point. Documentation, we can dynamically generate documentation. So we change the code, we rerun the documentation unit test, and it's up to date. Circular dependencies are not allowed. Now the next thing is access restriction. Yeah, I mentioned that, and let's go back to the code to talk a bit about access restriction. Let's roll back what we've done. Now, the first thing that I mentioned was package private. So let's start there. For example, here in the review analyzer, you see there is no public keyword, so it can only be used in this package, as analyzer service, for example, does. But that's very nice, so it's encapsulated there. If I want to refer from another package, so let's do it here. Yeah, we already see that we cannot do it. It's the compiler at work here. I cannot compile this code, so I can also not start my Spring Boot application. That's very good. If you can encapsulate it in your package, please use that. But, well, as I mentioned, sometimes we need encapsulation on another level. For example, here we have this analyzer service. It's public. And why is it public? Because the review service uses it. So that is why we made it public. But we want to encapsulate that, and Spring Modulith offers that. Spring Modulith encapsulation rules is that by default, the classes that are directly in the module can be used by other modules. So here you see review controller, repository, and service. It can be used from other modules. Now, IntelliJ has support since 2025.2 version in the Ultimate license. So you see it here as well. A green open lock, it indicates, okay, according to Spring Modulith, it can be used from another module. So if you have IntelliJ Ultimate 2025.2 or above, and you add Spring Modulith to your POM, to your project, then you will get this visualization. Here, this is an internal package, so it's a red closed lock. And if I refer to the analyzer service from another module here, so let's do that, analyzer service, then, well, I cannot do it. And this is actually the IntelliJ support. So the compiler doesn't enforce it. I can ignore this, I can compile my code, and I can just start my Spring Boot. So developers could just do that, or you don't use IntelliJ. It's not a problem. You can still force it because the unit test will fail with the same message. actually. Module bidding depends on non-exposed type analyzer service. And non-exposed means it is in an internal package. So this is very nice. It gives me extra power encapsulating stuff on a level other than just the package that the compiler already gave me. Now, it can be that, well, we have a structure here in review with all kind of internal packages, but one of them I decide, yeah, I want to expose that to the world. So we can do that. We can override the default that it is closed, and you can do so as a lot with Spring Modulith by declaring that in your package info. So in my package info, I say this is a named interface, and you can, well, you can give that a name, but if you don't do that, it's just the name of the package. And as you see, the green lock, well, the red lock became green for the IntelliJ support. No red lines here, and well, the test also passes. So I can overrule that and relax a bit on the constraint. But I can also do it the other way around. So instead of relaxing a bit, I can constrain myself more and be explicit on what module dependencies I allow. So yeah, let's delete this. And here we have the review service, for example. This one is public, so the compiler says you can use it everywhere. It is directly in the module, so Spring Modulith also says, yeah, you can use it everywhere. So let's use that from my bid service. That's no problem. But now, suppose that from our architectural IDs, we want to allow bidding only to use the freelancer module. And that's possible. We can be explicit about what dependencies we allow. Again, with the package info, and we declare this application module and enumerate the dependencies that we allowed. And in this case, we can do a freelancer. Again, for the support of IntelliJ, if I do this, it tells me, okay, freelance is not a module. So let's do this. Then it tells me here, module bidding depends on review, but the only allowed dependencies are freelancer. And again, I can just ignore this. It's not something the compiler forces me to do. But if I rerun the test, it fails. So I will never get my build green if I violate against that. Yes, that's what I want to share about access control. First thing always to check is, can I use package private? Just use what Java already offers us, and it's also the biggest force because the code doesn't even compile if I violate against that. If I want to encapsulate on another level, Spring Modulith offers us a way to do that, to encapsulate within my module. Because internal packages are closed, I can encapsulate stuff in that module. That's very good, but I can customize it. So I can open it to the world or even restrict me more. The support of IntelliJ that you saw, I listed here, it's only IntelliJ Ultimate 2025.2. So now maybe by now you think, okay, I often feel like the guy with that exploded head. Maybe this vertically slicing, package encapsulation, Spring Modulith can help me. So how do I add Spring Modulith to my project? Well, add it to your pom.xml, add the single line unit test, and you have Spring Modulith on your project. But you can imagine what happens if you do that on an over 100,000 line code base, like we did. It's not a handful of violations. It's a huge list. So what you probably do is disable the unit test and start refactoring your code in order to comply to the conventions of Spring Modulith. But your code base is alive, isn't it? Because otherwise, why would you bother adding Spring Modulith anyway? So there are features requested. and maybe even bugs. I don't know. We had bugs by then sometimes, but reasons to modify our code. And by modifying that code, you might introduce new violations. So while on one hand you are refactoring in order to comply to the conventions, on the other hand, new violations are introduced. And you're basically like this guy. Who knows who this is? Please yell it. Sisyphus, yes, exactly. This is Sisyphus. Sisyphus, he did some nasty things in the ancient Greek world, and then the gods decided to punish him. And that is really, the gods didn't say, Sisyphus, you have to pay a fine, or Sisyphus, go to jail for a while. No. That is not how those ancient Greek gods were. They told me, hey Sisyphus, here you have a big rock, there's a mountain. Please push it up, and when you're almost at the top, it rolls down and you have to start all over again. I think that's way more funny than the way we punish stuff. In the Netherlands, we have our equivalent that is not that nice and dramatic. It's called dweilen met de kraan open, which literally translates in mopping while the tap is running. Not such a nice story as those ancient Greek guys, but still it covers the situation where, basically, you want to gradually introduce stuff. So we want to refactor a part of our code to comply to the conventions of Spring Modulith, protect that part with the unit test of Spring Modulith, so no new violations are introduced there, but ignore the rest in violation for the time that we need to refactor it, because we want to keep our build green. Now, how do I do that? Well, we went through it, and I want to take you with me into the things that we tried and what, in the end, worked for us. So, let's roll this back and switch to the fat service package branch. And basically, this is the exact same application with one extra module. The service module. And this service module in our situation had, including sub-packages, over 100 services, and we had multiple of those service-like packages. But in this case, for demo purposes, I just have one. And we can assume that bidding, freelancer, and review here are okay with Spring Modulith. We already did that. So we want to protect those. But services work to do, and that will take us a while. We cannot fix that overnight. Now, if we rerun the test here, we see that there is a circular dependency that has service involved. Now, what we want is, to ignore service. The first thing to try, maybe, is to make this an open module. And an open module, again, we can do that by adding that in the package info. You do it like this. Of course, by default, the type of a module is closed. If you make it open, there are two things. Its involvement in circular dependencies is ignored, and the internal packages can be used from outside. So that seems something that we could use, and the test passes. However, for us, there was a problem, because if I refer from this to, for example, that analyzer service that I mentioned, there is still this problem. The test fails because the analyzer service here is an internal package of review. Now, I could make review an open module as well that would solve that, but then I lose my protection of review. So I don't want to do that. There's nothing wrong with review. I want to protect that. So this solution didn't work for us. Now, the second thing that you can do is to hook into the module detection strategy. And by default, it is direct subpackages. So that's why we have 4 modules here. But we want to ignore the service here. Now, let's first modify our unit test here quite a bit to make use of the, let's say the toString implementation of it. Now, if we rerun the test, then of course it still fails, but it prints the modules that it validates. So it has bidding here, freelancer, review, and service. And basically what we want is not having service here. We can do that by being explicit. So if the module detection strategy here is by default direct subpackage. We can make it explicitly annotated, meaning that a module is only a module if we explicitly say it is a module. Now, my test passes because nothing is defined a module, and we can define something a module by declaring that in the package info. So if we would do it like this and make this an application module, then we explicitly say, okay, this bidding here, this is a module. Now we run the test, and well, we say we validated bidding. That could have worked for us. This is a nice solution. It could have worked. Only that there is one thing that we didn't really like about it is that we had to add all those package info to our production code. Now, maybe that's not too big of a deal, but there is even a third solution that allowed us to only modify our test code, and that is to create our own custom module detection strategy. And you can do that by creating a class, and let's call that my module detection strategy. And what it has to do is it has to implement the application module detection strategy, which has, well, basically one method that we really have to implement, and that returns the modules. So those are objects of the Java package. Now, if we look into this interface, then we see quite some things, but one thing here is direct subpackages. And basically this is the default strategy. And we like the default strategy. That was always our goal in the end. That's where we wanted to end up. So what we did is we decided to use that as our base case here in our own implementation, and start from there. So basically, if we use this strategy, we are back to the default. But because we made it explicit, we could filter on the stream. And package here has some properties that we can filter on. And for example, the local name here is the name like I referred to, like bidding, freelancer, review. And that seems an excellent candidate for us to filter on. So we use that, and if my modules contains that package name, then we consider that a module. And my modules here, yeah, let's create it constant. It's not a marker list. It's a set of string. And, well, here we can be explicit on what we think should be a module. And in our case, that is bidding, freelancer, and review. Now, basically, this is a strategy that we want to use. The only thing we need to do is to tell Spring Modulith that it should use this class. So recall that here we can fill direct subpackage. We can fill explicitly annotated or refer to a class. Now, if we rerun our unit test here, then we see it passes, and we see exactly why. Because bidding, freelancer, and review is validated. And that way, we could gradually introduce it, so let the number of modules in the set grow until our entire application was covered. And then we just deleted the class, deleted the configuration here in the application YAML, and we were good with the default strategy of direct subpackage. And well, we are still today, we use that. So basically, to recap on Gradual introduction, an open module, it could be of use, but it doesn't protect you to referring to internal packages from another module. explicitly annotated. You can do that. It could have worked, but we had to modify our production code, so we preferred the custom strategy. Now, in this talk so far, I often mentioned, okay, then we change our code, we refactor stuff. But yeah, how do I do that? It's not always that easy to change the code. So I want to share with you the 3 refactorings that we used most in order to comply to the conventions of Spring Modulith. So let's go back to the code. And yeah, let's roll this back. Basically, the first thing is the simplest one, because always aim for the most simple solution that is available. And the most simple one is to move code. So that's applicable if the code is kind of on the edge of 2 modules. For example, here in my freelancer controller, I want to return the number of bits per day for a certain freelancer. Now, we can implement that, but if we rerun the test here, then it fails because, well, we refer to the bit service here, and it caused a circular dependency. Now, in this case, functionality is kind of in the middle of the freelancer and the bidding, so the simple solution is just to move it to the end of the direction of the dependency that you allow by your design. So we can do that here and just move it to the bit controller, and basically that solved our problem. But of course, this is a very simple solution. That's why we always tried it first. It not always works, because sometimes code is in the right place and still causes us problems. For example, in the freelancer service, suppose we want to set the minimum bid. So basically the functionality here is that, okay, we have a certain freelancer, and we want to set the minimum bid in cents for that freelancer. And we call the freelancer service here to do that. So we fetch the freelancer entity here, and we set the minimum bids. Yes, and then we have some freelancer-related logic. Now, there could be bids for this freelancer that are below this new minimum. So we want to decline that, and who can do that better than our bid service? So we create the functionality there, and we're done. Okay, now we run the unit test, and yeah, you by now know what happens. We introduce a dependency to the bid service, so it fails. First question, can we move this code? Not really. Setting the minimum bid, it seems like a responsibility for the bid service. And here in this example, we just we just tell the bid service to do stuff, but maybe there are other services from other modules that we tell that. And to what module are we going to move it then? So the solution in this case, that instead of telling the bid service what to do, we tell the world that something happened by publishing an event. And basically this code is almost similar, but here was the bid service reference, and now it is the application event publisher. That's just the application event publisher of Spring. And this line changed. Instead of calling the bid service, we publish an event. So let's create that, and an event, it can just be a record. And I don't know, since Spring 4.2, you no longer need to extend application event. It can just be a record here. So here we are. We broke our dependency. So that's one thing. But we lost functionality. So we have to let our bid service still listen to this event. And we can do that here. And let's import that. Okay, yeah, you see here there's a problem with my minimum bit event because it's not public. I asked you, well, if you create a new class in your IntelliJ who thinks about whether you should omit the public keyword, you can do it the other way around. Let me show you how. If you go to Live Templates in IntelliJ, then you see here File and Code Templates. And here I have class. If you do that by default, here is the word public with record as well, and well, with enums interface as well. I removed that keyword. So if it turns out that I need it to be public, the compiler will tell me. If you do it the other way around, if it is public, the compiler will never tell you that you should not do that. So that could help you in making it a habit of reasoning about whether do you really need this class to be public. Just configure IntelliJ such that it's not public by default. But that having said, okay, here we are. I think IntelliJ doesn't see yet that I exposed that. We can listen to this event in various ways. Here, the event listener, it just is in the normal flow, and we can go a bit through that. Let's split and move right. So basically, if we use just a normal event listener, then it is the same flow as if we would have used the code here. So the event is published, then this is run, and then this code continues. Means it's also in the same transaction. Huh? So if an exception here is thrown, this is rolled back. If an exception is thrown here, this is rolled back. Might be what you want because you have transactional consistency, but it has a lesser level of decoupling. So that might be what you want. It might be not what you want. Then you can do it in a different thread. For example, to write to a log, then do it in a different thread, and it has no transactional context. It might be that you only want to do a certain action if the transaction is committed. So this transactional event listener means only run this if the transaction in which this event was published is committed. That's maybe a bit of a confusing name because it has no transactional context itself. For example, to send email notifications. If you need a transactional context yourself, then mark it transactional. For example, to store those notifications, you need a transactional context. Yes, and Spring Modulith also has a very good way to store those events and to, well, rerun them in case something fails here. But yeah, I won't go into detail on that, but it might be interesting. You can look into the documentation for that. So it replays kind of those events that were failed when processing them, when listening to them. So that basically concludes the second refactoring that I wanted to show you. And there's only one left. And that is, for example, in this case, where we get a freelancer DTO from our freelancer service. Yeah, let's make that a class. And that class can be public. So we build it here, and then we add all kind of values according to freelancer-specific logic. And then, depending on whether this freelancer has bits, we have some logic to follow. And if it doesn't have any bits, then there is other logic to follow. Now, who can we ask that better than our friend, the bit service? So let's create that method. Ta-da, and we're good to go. We implemented this functionality. But you already know what happens. We again introduce a dependency to the bit service, making it circular. Now, first thing, can we move this code? Now, we are talking about a freelancer DTO with freelancer-specific logic. It doesn't make sense. The freelancer service is the right place. Okay, can we use an event then? Well, not really. We don't tell the world here something happens. We ask the world something. We need an answer. Events don't give you answers. So what we can do then instead is, instead of asking this to the bit service, we ask this to an interface that we define in our own module, thereby inverting the dependency. So for example, we define a has bits checker. And well, let's define that. And make that public right away. And then, of course, we need to add it to our constructor. And what we do then is, instead of the bit service, we ask that to our own interface. And let's add that method here. So, and we're good to go. We broke the dependency to bit service. Only thing, we lost functionality, and that's kind of where the red line is here. There is no bean of that type. So who can answer that? Of course, our bit service can answer that. So let the bit service implement that. And here, here we are. We refactored the code to no longer depend on our bit service. And you can see why it's called inverting the dependency, because we started with the dependency from freelancer to bit service, so dependency from freelancer to bidding. We removed that dependency by asking it to our own interface, but then we introduced a dependency from bidding to freelancer, because bit service here implements has bit checker. But there's no problem with that dependency. We decided that bidding can be dependent on freelancer, and not the other way around. So that way you can refactor stuff, and if you need an answer, you can invert the dependency. So basically that was the third refactoring that I want to share with you, and well, recap that. First thing is move the code, basically because it's that simple. Always try the most simple solution first. If that doesn't work, maybe you can tell the world something happens, especially if you find yourself in your code just directing different services what to do. Maybe you can just tell the world and let them react to that. If you need an answer, that doesn't work, but you can invert the dependency by asking it to an interface in your own module. Now, that basically concludes my demo, and we're almost at the end of this talk. Now, if you think, okay, this Spring Modulith thing, it's really interesting. It's a pity that this talk will only last 4 minutes. Then I have some good news, because just in a few hours, Oliver Droodboom will talk about Spring Modulith. Oliver Droodboom is the creator of Spring Modulith, so kind of the mastermind behind it. If you like this talk and want to hear more, or if you think this talk is crap and I want to have a decent talk on Spring Modulith, could also be possible, then please go to the talk of Oliver. I will join you, I will be there. But for now, as a closing word, we started with this guy, with this exploded head. And I hope that maybe at least by some of the things you've heard today on package encapsulation or Spring Modulith, you have a little less days like this and a bit more days like this guy. Because, I think you, this audience, you are by far the best audience that and I don't want to be overly emotional or a bootlicker, but you are the best audience that I've had today, and I'm serious about that. So I hope you have a lot of days like this guy. And for now, I want to thank you a lot. You can scan the dinosaur here to get the code shown here in the examples, to get the slides, my LinkedIn profile. You can send me an email you see on the slides. I will be around here all day. You can ask me, you can come forward and ask me now. And for now, I really want to thank you for your attention. Thank you.